Yo, what's up? Day 19. Woo! Nah, I'm joking. We're gonna get straight into it. We're gonna do a few problems today. Going to Australia on the weekend, so exciting. Today's Monday when I record this, so yeah. I'm leaving Saturday, so it's pretty exciting. But yeah. Let's get to our planet of the day. I think we got Metis today. Let's see here, Metis. Jeez, Metis. Planet. Jeez, man, I couldn't think. Oh! We got a moon today. Finally, it is not an asteroid anymore. Lucky us. We finally got something actually cool. Moon sound. What? Metis moon. Metis is known as a Jupiter XVI. Is the innermost known moon of Jupiter. It was discovered in 1969 and the image taken by Voyager 1 was named in 1983 after the Titaness Metis, the first wife of Zeus and the mother of Athena. Interesting. Yeah, wow. Interesting. Let's take a look at this video, though, because I'm kind of interested with the sound. Check out the sound of the moon. The sounds of Metis. Whoa. I didn't know moons make sounds. That's so weird. Let's go to this guy's timestamp. Interesting. There's the sound of the moon. What a good start. Good start to the day. Let's go back to our list here. Take a look at what we're going to be looking at today. Okay. Average levels of a binary tree. So we're going to be looking at some BFS and DFS. Interesting. Probably going to have to relook at that. I know we've looked at BFS and DFS, but I don't have the best memory, so I think I gotta relook at it, to be honest. Coming up to 2-some again. Interesting. Okay. Alright, let's check out Leetcode. Leetcode, let me just respond to this text. Oop, that's my email. Whoops. That's okay. Okay. Let's go to our problems here. Oh, I got another easy problem today. Oh, man, I'm getting... Oh, man. And spam attacks. Okay. Given the search that consists of some words separated by single space and a search word, check if search word is a prefix of any word in sentence. Turn the index of the word in sentence where search word is a prefix of this word. Search word is a prefix of more than one word. Turn the index of the first word. Minimum index. Search word is a prefix of more than one word. Return the index of the first word. Minimum index. If there is no such word, return -1. A prefix of string S is any leading contiguous substring of S. 2-pointer string, string matching. First extract the words of the sentence. Check for each word if search word occurs at index 0. If so, return the index of this word. Search word doesn't exist as a prefix of any word. Return the default value -1. I need to get off my phone, man. I need to get off my phone. Jeez. Okay. Let's lock in, baby. Let's lock in. I have to respond to this one. Jeez. Okay. How can we look at this from? Check for each word if search word occurs at index 0. If so, return the index of this word. Check for each word if search word occurs at 0. Okay, let's figure out. First of all, we need to slice by white space. I need to remember how to do these, man. The sentence dot split. What does that do? I wonder if this stores in an array. Probably does it? Oh, bless me. Oh my gosh. Oh. Jeez. sneezed all over myself. Ugh. I should have. Oh, that's because the first word is I. Okay. Alright, so I think that worked. For word in array. Before it occurs as a prefix. How to check prefix in a string. I think there's a way that we can do this actually. Starts with, okay. So word.starts. God, Python is such a cheat. Oh my gosh. Starts with for word. Wait, what are we doing? For word in array. Let's check. Does. No, I think we're meant to do array. No. Word.search. We were right before. No, sorry. Word starts with search word. If word.starts with search word. God, no, this is confusing. Let's just return. Word else return -1. I think this is meant to be capital W. Okay. I think word length array that starts with return Jeez, what are we doing here? I think the issue here is that we're not accessing the specific element, that we're returning the actual word when we want to return. We want to return like the ith value, like of the word. But I'm not sure how to do that. So they're using enumerate. I just don't really know how that works, to be honest. For yeah, we want to access the indices. That's so I was right. I doubt myself too much, man. Range, length, words. Oh wait, why do I have words here? We want array. Whoops. Array, what? Array word that starts with search word. Then we want to return word. Right? Return -1. shit, we need this outside. Whoops. Uh, 3, 1. Oh. There we go. 'Cause it's 1 based. Oh. Submit that. Nice. No one does this problem. Interesting. Okay. Nice, dude. Daily question. They've been kind of easy recently. That's good. Okay, let's go into it. Average levels in binary tree. See, I'm not very good with trees, to be honest. Average levels in binary tree. Okay. Given the root of a binary tree, return the average value of the nodes on each level in the form of an array. The average values. Given the root of a binary tree, return the average value of the nodes on each level in the form of an array. Given the root of a binary tree. Okay, so it's going through each level. So we have 3. So we're traversing the first, so obviously 3, there's only 1, so we return 3. Then we're getting the average of these, which is 14.5, and then the average of these, which is 11. But the averages can increase. This is a tough question, bro. What makes this turn into fun? Tree problems are just hard to wrap your head around, at least for me, bro. Like, so what does it give you here? We get the... define our array.
Today, I'm going to teach you breadth first search. Breadth first search, or BFS, is an algorithm from another these all the nodes that a node will visit. We pop A into the queue with C. Calls our algorithm full.
Alright, so breadth first search goes like this. I think DFS goes like this. Right? Or something?
Here's the code.
No, sorry. Boom, 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 boom. Wait, boom. Sorry, it goes here. Here. Okay. I'm just gonna watch the DFS for 4 minutes.
Today, I'm going to teach you depth first search. Depth first search, or DFS, vertically, is an algorithm for searching a graph. As the name implies, we'll use DFS to search a graph vertically before we proceed horizontally. When you think of depth first search, I want you to remember a stack, as this is the data structure that keeps track of vertices we'll visit. There's nothing less preferable from the line to putting track of the top A. We also add its adjacent first because I think it's easier to follow visually in the stack. We mark it as visited. Add B's adjacent nodes. C is the next B stack algorithm
I was right.
in the stack.
I doubt myself too much, baby. I was right. Oh, how to implement DFS. Jeez. How to implement BFS. See, I'm not sure how to implement this. Like, BFS user queue. Okay. Leetcode doesn't have a video on this one? I feel like Leetcode always has a video.
Hey guys, Greg here. Let's talk 0.5 and the last quick here because essentially you just need to know that you'd want to do a BFS, otherwise known as a level order traversal when you're talking about binary trees here. And video in the description, I'll link that up, and that's going to exactly get those averages of. So we are going to do a BFS in the tree, which means from collections, we'll import DQ. We need a queue object to do level order traversal. So we'll get a list of averages, which is what we'll return at the end. That's going to be an empty list so far. And we'll get a Q, which I'll just call the letter Q, is equal to a reference to a DQ object, which starts as empty, but we will put the root onto it. Okay, then while we have a Q, the average for our current level is 0, and we'll get N is the length of the queue. So the length of the queue means at this point, what is the length of the upcoming level? So at the beginning, it's just the root. After we process the root level, it will have put on its children. And so there'll be 2 things in the next level and 2 things in the next level. So here we do for underscore in the range of N. So we purposely run this N times, which will process 1 level. So this for loop here processes 1 level, which will have length of N. And so we need a node to pop off. We'll do node is equal to q.pop left. So we need to make sure to pop from the left side of the queue. That's what allows it to act as a queue. If you popped from the right side, then that would make it act as a stack still. So now it's a queue. The average for the level is going to go up by... the current node's value, and then we need to deal with setting up the next level. So if we have a node.left, then that needs to go on the queue, queue.append the node.left, and if we have a right, then queue.append the node.right. Okay, after we exit this for loop here, that will have processed that level, and right now average is really acting as a sum. You know, it started as 0 and we summed up all the values. To really make it an average, we need to do average is going to divide equal by n. So this sets average equal to itself divided by n, and that's what truly makes it the average for that level. So we have a new average, we'll just averages dot append that average, and after this while loop completes, we will be fully processed our tree, and we can safely just...
I always see this on TikTok, man. Algomap.io. Oh shit. Algomap.io, baby. 2-pointers. Done a lot of these 2-pointers. Stacks. Quiz. My research. Cocoa eating bananas. Ah, I hate this problem. Heaps, recursive backtracking, and graphs. I feel like once I get through this list, we got backtracking, sliding window. Wait. Damn, bro, there's no easy sliding window problems, they're all mediums. Sliding window is tough, bro. Like, alright. Maybe we will use this. Maybe I'll save this link. Come back later. Oh my gosh. Desktop. Always gonna need more problems, man. Problem grind never stops, dude. Okay, interesting. So I just want to go back and...
which is onto it. Okay, then while we have a queue, the average for our current level is 0, and we'll get n is the length of the queue. So the length of the queue means at this point, what is the length of the upcoming level? So at the beginning, it's just the root. After we process the root level, it will have put on its children. And so there'll be 2 things in the next level and 2 things in the next level. So here we do for underscore in the range of n. So we purposely run this n times, which will process 1 level. So this for loop here
interesting. Okay, let's implement it. So we have an array. We want to create out. I guess we want to import our queue from collections. I don't even know. Import DQ. Now we want to create a queue. Q is equal to DQ or something. I think it was something like this. Q.append. So then we want to append the root. That's how we begin. Alright. So while Q, we want to, I guess, have our average. Oh wait, no, we want to declare that inside the loop. It's going to be every single time. while q average is equal to 0. Right. We want to get the length, n is equal to the length of q. Then we want to do for this in range, and we want to loop through. Have this value. We're going to come in, average is equal to 0. Every value in the range, we want to increment it for the, is it like q.val, right, or something?
Do node to side of the q as a stack still. So now to q.
Okay. That is equal to q dot pop left. You want to pop the left.
The average with setting up the next level. So
And then we want to increment our average. Is it q dot val? Did I get that right? Node dot val. Oh. Yeah, we're not referencing a q, we're referencing the node dot val.
if we have a node dot left, then that needs to go in the queue. Q dot append the node dot left. And if we have a right, then Q dot append the node dot right. Okay, after we exit this for loop here, that will have processed.
So if we have a child node, we want to do if, what was the syntax? If node dot left, q dot append node dot left. If node dot right, q dot append node dot right. And then we want to outside of our loop, yes, don't we want to append our average to our array, right? When does he append that?
And we'll just averages dot up equal by n. And average sets at level. While loop completes, we will.
We want our averages is equal to average of n array dot append averages. Outside the for loop, I think. Or is it outside this while? No. Outside the for. Did I spell DQ wrong, bro?
Be level and
DQ. I spelled it wrong. DQ. Learn how to spell DQ as well. She, we want to return our array. There we go. So really, I think is BFS and BFS implemented through a queue and stack. Is that what makes it BFS and BFS? See, I didn't know the traversal. I couldn't remember about the traversal with BFS and DFS is uses the queue and DFS uses the stack, but that's actually the way that you see the nodes. So now I understand. That just blew up a light bulb in my head. That BFS is primarily like use is because of the data structure. Like BFS and DFS is because of the data structure, not because of the algorithm or whatever. It's like the same way you're traversing, you're going through it and doing it, but BFS is a queue and DFS is a stack. So that's really interesting. Maybe it'll help me be able to implement it next time. Interesting. Okay, let's jump to our next problem. Average, we did this one. Minimum depth of a binary tree. I think we've done this one. No, we haven't. Given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root down to the nearest leaf node. A leaf node with no children. I'm trying to think what would be the best way to... Would it be DFS? I don't know. DFS. I think DFS here will go like this. Right? And BFS would go... Is that the same way? I'm tripping. Let's just look at this again.
Following graph. We want to know all the nodes, two things. First,
Stop talking, just show me.
Is the first node we'll visit. We'll keep track of the stack in the top left corner. We pop A from the stack and mark it visited. We also add its adjacent nodes into the stack. I'm adding the rightmost node first because I think it's easier to follow visually if we go left to right. B is the next node popped from the stack. We mark it as visited. Notice G is the only node in the stack, but as we add B's adjacent nodes, G gets moved to the bottom. C is the next node will pop. Nothing. I'll let the rest of the algorithm finish without voiceover.
Difference between BFS and DFS. Trains here, baby. Stack is equal to this. Alright, we're gonna use stack. This is a DFS question. That's really just implementing DFS is the tough part. Nine is null null. Oh yeah, 15 7. Oh, looking for the minimum depth. Okay. So I guess we're just traversing until we see null. Right? Am I tripping? Or... stack.append root file stack. Guess we can implement it the same way, right? How will we keep track of the level though? stack.append node.left node.right stack.append node.right. Right, but I guess we could do if node is equal to 0 equal to null, we just want to return the, is that like a special like level or something? I don't know. Alright, then we just want to, otherwise we just want to return well, I guess we'll always achieve a null, right? I think. Last stack. Pop the last node as depth. Node depth is equal to stacked up pop. If node.left and node.right return depth. What? Trying to seek. Do we need this shit there? Oh, we got Q here. We need stack. Range and length then. We keep track of the level, that's what we're missing. But how does this keep track of the level? I don't understand. If not node.left and not node.right, turn level. Oh, we're incrementing here. If node.left, stack.append node.left, and then for level, we want to level plus 1, right? Yeah. Level plus 1. can we do level plus equal to 1 here? I'm not sure. Level plus equal to 1. I don't know. The level variable is reset to 0 inside the loop. Oh, it is. We need to put the level here. Oh. I don't understand here. Like, still really wants me to do this, bro. For some reason. +1. I hate AI, bro. Honestly, it's so shit. Level +1. Why does it want this? I don't understand. I don't get it. Return level. Node. Oh shit. We're not keeping track here. Root 1. Cannot unpack itaware object. I don't like this, bro. I don't like this solution. I don't like this solution at all. Append the root. We want a level is equal to 1 here, right? We want to loop through. Node is equal to stack. We want to return a level. If node, we want to append the left. We want to increase the level by 1. Right? Plus or equal to 1. We're increasing it both by 1. That's why we're getting 5. Right. We're increasing it both here, and I think that's why. Yeah, we want to increase it outside of this, not here. It goes through the 4. So equal 1, right? Yeah, we want to do it outside the 4 because the 4 is going to do each level. There we go. Nope. Not no dot right. If not no dot left. Has no attribute left. Oh, it's not root. So none. Out of 52. Expected 0. Could that be the answer? Nope. While stack range n node is equal to stack dot pop. If not node dot left and not node dot right, turn level. If not, why? This is the root. 2, 3. 2. Three. Why is it 2? The root. We've got stack. We have pin dot root. Level is equal to 1. While stack n is equal to length stack for this in range n, node is equal to stack dot pop. We pop 1 from the stack. If not node dot left and not node dot right. If it's empty, we just return the level. If there is a node dot left, which there is, and there's node dot right, we append these. Alright? For n and stack, then we look at this one. For 2, if we have outside the 4, is that why? I don't know what's wrong here. Leetcode, technically a BFS approach. Increment level. We need to get rid of this for loop, I think. Okay. You want to use DFS, like, let's have a look how to implement DFS.
Welcome to October's Leetcode show. Two approaches you can go with, depth first search or breadth first search. Either one work. Welcome to which doesn't go through depth first search, or we can go breadth first search. A child value in return 0. This will have to be stored as the minimum, right? So I'm going to start off with the highest number possible, infinite. Next we'll have a depth first search. And what I'll do is pass in the current node as well as the number of nodes we've seen so far. So first thing is, if there's not node, we just go ahead and return. And if there's no children, if not node dot left and not node dot right, that means this is a leaf. So what we'll do is update our self variable as the minimum between self.
I don't like this guy's explanation.
Hello and welcome to another Leetcode video. Today we're going to be doing the problem of the day for July 10th. Hello and welcome to the binary tree. And I'm going to show you the recursive solution without using any extra variables like a level or anything. We're just going to go through the logic here. And so in this problem you're given a binary tree and you are asked to find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. A leaf node is a node with no children.
Do our root and our level, right? Let's put that is equal to the highest possible. Okay. While we go through, we want to do node and depth is equal to stacked up pile. If node dot left and node dot right, return level. I go through this level plus 1 and level plus 1. Level is not defined. What do you mean level is not defined? Name levels outside, did you mean eval? What? Oh shit, what am I doing? It's meant to be 1. Let's switch this to level. I don't like depth. Level. Depth is not defined. Let's change this to min level as well. I don't like depth. Min level. Or return, it's level. Immediate return. Okay. Interesting that BFS is faster. BFS and DFS. Okay. Let's do the BFS. So this was the DFS approach. Let's do the BFS approach. Do it in the other one. So first we want to, let's import our, how do we import our fucking queue or whatever? From collection import DQ. Import DQ. Right? Is that how you spell it? Import DQ. Yeah. Okay. What do we want to do? We want to create a queue. So queue is equal to, how do we initialize it? Q is equal to DQ. Okay. Q is equal to DQ. Q dot, we want to append the root, right? Then we want to do our while Q. We want to initialize our level. Oh shit. Alright, we want our level is equal to 0. And then we want our line is equal, we want the length of our queue, right? For this in range n, then we want to add our level, right? not root, if not root dot left, and not root dot right, we just want to return our level, right? And if root dot left, we want to q dot append root dot left, root dot right, we want q dot append root dot right. Right, then we want to increase our level outside here, outside our 4. Let's see if that gives us. We want to turn our level. We want an infinite loop here. Why do we have a memory exceeded? Our level is equal to 1, actually. Maybe we need our, do we need our level outside? Is that what I'm doing wrong? Oh my god, we're not even popping our node. Node is equal to node dot pop left. PFS we always want to pop left, right? Sorry, node dot left. Node dot right. Node. Node. Variable node reference before assignment. You're popping the queue, dude. Come on, bro. Come on, bro. There we go, there's that queue solution. Ah, man. Hate this. Object has no attribute left. Oh. God, do we have root on here at all? Any more root? Okay, thank God, dude. Jeez. There we go. Okay, really the difference between let's kind of learn out difference between VFS. So this is our VFS solution. Python. This is our VFS solution. VFS solution. So learn the difference, man. I know what the difference is, but I just like want to learn more. Depth first search explores as far as possible down a branch before backtracking. Processing all nodes at one depth before moving deeper. Okay. Works a little bit. I think I'm gonna take this day as a dub. I know, like, these past 2 questions, we kind of needed a little bit of assistance, but I actually learned a lot thinking about it. It's because the data structures class I took was like, I mean, 3 years ago now. I think I took it fall 21. So yeah, it was like a long time ago. So it's like, this is all like such a big refresher. Like I learned about trees, and I learned about depth first search, breadth first search, but it's like, you know, I had to like really think about that. Like I couldn't really remember how breadth first search and depth first search works, but I think that's something for sure that I should continue to look at, because breadth first search, the difference between breadth first search is that breadth first search, what's the word? Okay, explore, yeah. Breadth first search explores all nodes by level. So if we have our tree, 2, 3, blah, 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 right? It goes, explores this level, starting from the left, and then explores this level, starting from the left, right? But instead, I think what DFS does is that it explores from this way, backtracks up here, this way, backtracks up here, and this way. That's what I think. Pretty sure that's how that works. But let me know in the comments if you do see this part, you know, like I'm doing that first search and breadth first search wrong, like the way I'm thinking about it, because I'd love to know. I definitely got to keep looking at some stuff on YouTube or something and keep looking into it deeper, but I was a little confused earlier, like kind of when we first started, like the first couple episodes. I think we did a little bit of depth first search, breadth first search from memory in the beginning episode, so it's like learning this, I think will help me. So, well, like this refresher here, like helps me a lot, and it helps me like kind of more think about these tree problems, because I was really scared of tree problems. Like I found them really tough. I didn't understand like most of it. I was doing a lot of recursive approaches too, so that probably wasn't really helping as much either, because I wasn't really like learning the fundamental. But I'm happy that I did look at some videos and learn the fundamental side of the recursive approach. But then maybe we can start implementing the recursive approach. But yeah. Sweet. I will see you guys tomorrow, and we will, looks like here that we're going to continue doing a lot of BFS and DFS, so I think it should help. So, all right. See you guys later.